title of the project is a real-time augmented reality system to see through cars. One of the most hazardous driving scenario is overtaking of a slower vehicle. So to avoid this, in our project we using real-time augmented reality system and see-through system. The term augmented reality system means it will produce a virtual image of the real one, and see-through system means it will help us to solve the problem of visibility. Here, the front vehicle is being overtaken can occlude an important part. The term occlude means the front vehicle will totally cover the important part in front of the front vehicle. So in the field of view from the rear vehicle driver, he can't able to see the important part which is occluded by the front vehicle. So due to this lack of visibility, the accident is occurring. So it works tend to prove we implementing the augmented reality, which will help us to reduce the risk of accident. From this information, here the front car will generate the unconcluded image from the rear car viewpoint. It will produce the important image present in front of the car to the rear car viewpoint, and we have to reduce the bandwidth consumption. So only the region of image which is affected by the front car will be transferred to the rear car. In this previous system, they used a grid-based sampling method, which will reserve a certain number of features to a homogeneous spatial distribution of the features, and again we have to obtain this to a stereo correspondent of that sample features. So these features will be satisfy the popular constraint which are kept as inliers. The term inliers means the combination of RGB, that is red, green and blue colors. So from this existing system there are some disadvantages. It will be not a real-time markerless system when it to a see-through cars, and the occlusion, the part which is covered by the front car, will not display to the rear car. It will only covered by the front car itself. And the ADAS, advanced driving assistance system, will change our perception of transportation safety. So to overcome this limitation, in our proposed system we implemented detection and visualization of hazardous vehicle driving system. Here a navigation and a control system will be included, a sensor configure which is help us to locate the object in a predetermined field of view from the vehicle. The sensor will configure to a scan of beam, which will produce a two-dimensional sector plane, and this first predetermined axis of the vehicle, and there will be a detector which help us to detect the reflection of the emitted beam from one of the object. The advantages of this project is it will reduce the transfer delay, and the visibility which help us to reduce the reaction time when the driver is need, and it will help us to successfully avoid the hazards. It will be a realistic seamless see-through effect when it taking in account of structure of the scene. The application of this project are, it will be a stereo vision system, and it helps us to generate a 3D map of the environment, and it produces a 2D 3D tracking strategy to localize the rear car. In every new frame of the front vehicle, a 3D pose will be produced, and a 3D computed pose will be produced with the approach of visual operometry. A relative 60 pose also will be generated in every new frame. The system requirement for this project is MATLAB 2014A, that is mathematic reliability, and the tools used in this project are image processing and computer vision tools. We using some techniques in this project. The techniques we used in this project is visual odometry and mapping. The term visual odimetry and mapping is nothing but it is a relative 60 pose and a new 3D pose it will produce in front of the front vehicle, and this will be proposed as a VO approach, and this approach will only have two stereo images, that the current one and the previous one. It consists of four methods, that is feature extraction. The feature will be extracted in this first step, and feature tracking in the second step. The feature which is obtained will be tracked, and the third step is robot pose estimation. The feature will robots as the pose estimation, in which pose the image is obtained. And the fourth one, local bundle adjustment. The poses which is estimated by the third step will be collect as a local bundle and it will get adjust. And the second technique is localization of the real car. Here the 3D map is generated from the front vehicle, which help us to localize where the part is occluded by the front vehicle in the rear vehicle viewpoint. And to avoid the 3D map from going unnecessarily, the points located near the rear car are systematically decimated. So the future work for this project is we can increase the number of frames per second. FPS is means number of frames per second. Here they used up to 15 frames per second. In our future work we can increase more than 15 FPS, and in previous future work of this project, it will become very versatile and easily because increasing the frame per second.